Welcome to another lesson of Math 0420, Introductory Algebra. In this video, we will be discussing Section 2.5, an introduction to problem solving. In this section, we will translate English phrases into algebraic expressions and solve algebraic word problems using linear equations. Let's get started with a strategy for solving word problems. A strategy for solving word problems. Step 1. You want to read the problem carefully. Several times until you can state it in your own words. What things are given to you, and what the problem is asking you to find. We will let x, or any variable you choose, represent one of the unknown quantities in the problem. Then, if necessary, write expressions for any other unknowns. Other unknown, not unknowns, but unknown quantities in terms of x. Then write an equation in terms of x that translates or models the conditions of the problem. Next, you want to solve the equation and answer the question the problem asks. And finally, you want to check the solution in the original wording of the problem not in the equation you derived or created. Okay, so those are some general steps that we can use to solve problems. Let's try an example. Okay, example 1. 4 subtracted from 6 times a number is 68. Find the number. Well, we know that we want to let x be the number. And we want to really digest what this problem means. So 4 subtracted from, so whatever we're subtracting from, it's going to have a -4 in it. Okay? 6 times a number. 4 subtracted from 6 times a number. So 6 times the number is 6x. And the word is implies the equals sign. Is 68. So that means that 6x minus 4 is equal to 68. Now we have a linear equation, which we can solve by adding 4 to both sides. And you get 6x equals 72. To isolate x, we divide both sides by 6. The 6's on the left-hand side will cancel, and you get x equals 72 over 6, which is equal to 12. So 12 is the number. Remember when problem solving and working through word problems that you want to go back and check to make sure that that makes sense in the context of the problem. So we have 4 subtracted from 6 times a number. So 6 times 12 is 72. If we subtract 4 from that, we get 68. So that means that we did everything correctly. All right, let's do another word problem example. Example 2. This one has a lot more words in it, so pay close attention. Only once in 1991 were the winning and losing scores in the Super Bowl consecutive integers. The New York Giants beat the Buffalo Bills in a nearly error-free game. If the sum of the scores was 39, determine the points scored by the winning and losing teams. Okay, so we first want to determine what x is. So we're going to let x be the number of points scored by the losing team. Which is Buffalo. Okay? So, let's walk through this problem again. So, in 1991, the winning and losing scores in the Super Bowl were consecutive integers. What does it mean to be consecutive integers? Well, it means that the whole numbers are one after the other. So, if it was 40, if one score was 40, the next integer would be 41. Okay, so that's something that we're looking at. So the Giants beat the Bills, and the sum of the scores was 39. That means when you add their scores together, it equals 39. So we've decided to let the number of points scored by the losing team, which was Buffalo, be X. So how many points did the Giants score? Well, they beat the Bills by 1 point, right? Because they're consecutive integers. So the Giants must have scored X plus 1 points. We're just adding 1 point to what Buffalo scored. Well, what happens if we add their scores together? We know that the sum of the scores was 39. So if I add what the Bills scored, which was X, and what the Giants scored, which was X plus 1, if I add those together, I should get 39. So on the left-hand side of my equation, I can combine like terms and have X plus X, which is 2X, plus 1 is equal to 39. Well, this is a linear equation that we know how to solve. So what we can do is we can subtract 1 from both sides, and we get 2X is equal to 38. Now we can isolate the variable X by dividing both sides by 2. 2's will cancel on the left-hand side, and you get X equals 38 over 2, which is 19. So what is X again? Let's go back and recall that X was the number of points scored by the losing team. So the Bills scored 19 points. How many points did the Giants score? Well, the Giants scored 1 more point than the Bills scored, so the Giants scored 20. Okay, let's do another example. Example 3. A taxi driver, maybe we should choose something a little more modern. An Uber charges $2 to turn on the meter. That seems a little old-fashioned too. How about charges $2 to pick you up? Plus 25 cents for each eighth of a mile. If you have $10, how many eighths of a mile can you go? How many miles is that? So, to solve the problem, we want to let X be the number of eighths of a mile traveled. So, what we know is that for every eighth of a mile traveled, we're going to get charged 25 cents. So for every eighth of a mile, we are charged 0.25, 25 cents. And just to pick you up, you're charged $2. So this model, 0.25x plus 2, is the cost of a ride. So if we want to look at what happens on $10, how far we can travel, we want to take our model, 0.25x plus 2, and say that's equal to 10. Well, again, this is a linear equation that we know how to solve. We can subtract 2 from both sides of the equation, and we get 0.25x is equal to 10 minus 2, or 8. Now we can isolate the variable x by dividing both sides by the coefficient in front of x, which is 0.25. So 8 divided by 0.25 gives us that x is equal to 32. So you can go 32 eighths of a mile for $10. Well, an eighth of a mile, 32 eighths of a mile is really 32 over 8. 32 over 8 would be 4, or 4 miles. That's how far we can travel with $10. Okay, make sure that you go back and check to see if that makes sense in the context of the problem. Does it make sense that you could travel 4 miles for $10? Well, if you take away $2 for the original fee of getting in the Uber, then it makes sense that you could spend $8 and go 4 miles. Okay, let's do another example. Example 4. So a rectangular soccer field is twice as long as it is wide. If the perimeter is 300 yards, what are the field's dimensions? Okay, so in this case, I want to let x be equal to the width. You also could use w if you wanted to, that's fine. We know that the length is twice the width. Well, if the width is equal to x, then 2 times the width is equal to our length. If you remember back into our last section, we found that the formula of the perimeter of a rectangle is 2 times the length plus 2 times the width. Do we know what the perimeter is? Well, we know that the perimeter is 300 yards. So 300 is equal to 2 times the length. Well, the length is 2x, so 2 times 2x, plus 2 times the width, which is x. Okay, now we have a formula that is a linear equation that we can solve for x. On the right-hand side, we have 2 times 2x, which gives us 4x plus 2x is equal to 300. We can combine like terms. 4x plus 2x is 6x. So what we end up having, we can divide both sides by 6. The 6's will cancel on the right-hand side, and we get that x is equal to 50. Well, let's remember back to what x was. Well, x was our width. So this x equals 50 is our width. What about our length? Well, our length is 2x. Well, 2x is equal to 100 because 50 times 2 is 100. So that is our length. So if we were to draw this out as a picture, our rectangle would have width of 50 and length of 100. So that would be the shape and the dimensions of our soccer field. Okay, be sure to go back and check to make sure that that makes sense. In this case, it does. Let's try another example. Example 5. Now this is an example you'll see on your homework, and you'll probably see something similar on your test, so be sure to pay close attention to this one. So 2 consecutive page numbers in a book two consecutive page numbers in a book sum to 167. Find the page numbers. Okay, so we need to let x represent some quantity. We have 2 different pages, so we can say that the first page is x. So let the first page number be x. Okay, so if you know what the number for the first page is, and it's x, well, what's the next page in a book after a certain number? What do you add to it? Well, it's consecutive, so the second page is one more than the previous. So we have x. How do you do one more than something? Well, you add 1. Okay, so if we take those 2 numbers, x and x plus 1, we know that those 2 things add up to be 167. So x plus 1 equals 167. Okay, on the left-hand side, we can combine like terms. X plus x is 2x plus 1 equals 167. All right, we can subtract 1 from both sides to get 2x equals 166. We can isolate the variable x by dividing both sides by 2. Those 2's will cancel on the left-hand side, and you have x is equal to 166 divided by 2, or 83. That means that x plus 1 is 83 plus 1, or 84. So if we add 83 plus 84, those are obviously consecutive numbers, right? 83 and 84 consecutive. So 83 plus 84 is equal to 167, which is exactly what our problem told us, is that the sum would be 167. So the page numbers we're looking at are 83 and 84. Okay, example 6. So after a 40% price reduction, an exercise machine sold for $564. What was the exercise machine's price before this reduction? Okay, so first we want to let x represent one of the unknowns. So x can be the original price of the machine. Two, we want to represent other unknowns in terms of x. Well, the only thing we don't know in this problem is the original price of the machine. So there are no other unknowns. Okay, and then we want to write an equation that models the conditions. Well, in this case, we know that if we start with our original price and we subtract off 40% of that original price, or 0.4 times x, we should get the new price of $5.64. Well, that's 1 times x minus 0.4 times x equal to $5.64. So solving the problem, one minus 0.4 is 0.6x equals $5.64. So we can divide both sides by 0.6. And we get that x, after those the 0.6's cancel, is equal to 940. Then our last step is to check, which we can plug in 940 minus 0.4 times 940. And we get 940 minus 376. And 940 minus 376 is 564. So that means that we did this correctly, and we can move on to another example. All right, example number 7. We want to solve the equation and check the solution. So we have 0.01 times x plus 15 minus 0.15 is equal to 0.01 times the quantity 6x plus 15. Okay, and what we can do first is we can divide both sides of the equation by 0.15. Sorry, 0.01, not 0.15. Which will cancel on the right and in the first term on the left. And so we end up with 0.0. We end up with x plus 15 minus negative 0.15 divided by 0.01, which is a minus 15. And then on the right-hand side, we have 6x plus 15. Okay, so x is equal, x plus 15 minus 15 gives us just x, and x is equal to 6x plus 15. Okay, we can subtract x from both sides, and we get 0 is equal to 5x plus 15. We can subtract 15 from both sides to get negative 15 is equal to 5x. And we can divide both sides by 5. 5's cancel, and we get x equals negative 15 over 5, which is negative 3. So there are a number of ways you could have solved this. You could have started out by distributing that 0.01, but as long as you follow the addition and multiplication rules of equality, you'll get the same answer. So the solution set for the equation is the set containing negative 3. All right, let's do example number 8. Example 8. Evaluate the algebraic expression for the given value of the variable. And our equation is negative x squared minus 2x. And we want to evaluate at x equals negative 4. Okay, so we plug in negative 4 for x. Negative 4 squared is positive 16. So the negative outside makes that a negative 16. Negative 2 times a negative 4 gives us a positive 8. Negative 16 plus 8 gives us a negative 8. So when we evaluate that expression, we get out negative 8. Example 9. So in a certain state, speeding fines are determined by the formula that follows. And that's F equals 5 times the quantity x minus 50 plus 75, where F is the cost in dollars, cost of the fine if a person is caught driving X miles per hour. Use this formula to determine how fast a person was speeding if the fine comes to 200. Okay, so let's remember that our formula is F equals 5 times the quantity x minus 50 plus 75. So what is F? Well, F is what our fine is. Our fine is 200. So 200 is equal to 5 times x minus 50 plus 75. We're looking for how fast they were speeding, so we will solve for x. Now we can get rid of the 75 on both sides, so minus 75. So we get 125 is equal to 5 times x minus 50. So we have 5 times that quantity, so we can divide that out. Divide both sides by 5. The 5s will cancel. 125 divided by 5 is 25, which is equal to x minus 50. And now we can solve for x by adding 50 to both sides. So x would equal 25 plus 50, which is 75. So the person was going a speed of 75 miles per hour, which caused them to get a fine of $200. So we can check that. 5 times 75 minus 50 is equal, plus 75, excuse me. Well, that's equal to 5 times 75 minus 50, which is 25, plus 75. 5 times 25 is 125 plus 75, which gives us a total of 200, which is what we would expect since that was the fine that the person paid. Okay, let's do another example. Example 10. The cost of living went up 7% last year. Alice got a 7% raise. She makes $26,340 this year. What is our unknown? Well, the unknown is how much she made last year. So X is how much Alice made last year. Okay, so we know that 1 times X, the amount she made last year, plus 7% of that, or 0.07X, is equal to her current salary, which is $26,340. Well, 1x plus 0.07x is 1.07 times x, which is equal to 26,340. We can divide both sides by 1.07 to get that x, after the 1.07s cancel, is equal to $24,616.82. Now, does this make sense? Well, you could check it and make sure, which you should, but intuitively we should know that if she's making $26,340 this year and she had gotten a 7% raise, that her salary for last year should be less than $26,340, which is at $24,616.82. Let's do another example. Example 11. Find the solution set for the following. We have 11 over 6 times x minus 8 is equal to x over 2 plus 16. Okay, so what do we want to do? How are we going to get rid of these fractions, which is the first step I want to take? Well, I have denominators of 6 and 2. My least common multiple of 6 and 2 is going to be 6. So we can multiply both sides of the equation by 6. 6 times 11 over 6 is just going to be x. 6 times negative 8 is negative 48. On the right-hand side, you have 6 over 2, which is 3 times x. And 6 times 16. What is 6 times 16? Is 96. So plus 96. Now we can add 48 to both sides. What is 96 plus 48? Well, that is 144. Now we can subtract 3x from both sides, and you get 11 minus 3, which is 8x, equals 144. We can divide both sides by 8 to get that the 8's cancel, and x is equal to 144 divided by 8, which means that x is equal to 18. Now you can plug back in and check, which you very likely should do if you need more practice. I'm not going to do that here, but I will write that our solution set, which is what we were asked to find, is the set that contains the number 18. Okay, that is the final example from section 2.5, an introduction to problem solving. Good luck on your homework. Be sure to reach out if you have any questions, and I'll see you in the next one.